Hello, I'm Gareth. Welcome to Somewhere on Earth. And we're here to give you your regular dose of technology from around the world. I'm not alone. We have the excellent Ghislaine Boddington here today. Hello, Ghislaine. How are you?
Hello, Gareth. Really happy to be here with you, yes.
Marvellous. Settling into this new groove well?
Absolutely. And we can keep our chatting going and cross over on all our new ideas and the things that are shocking us and the things that are positive.
We sure can. And were you rocking with my very casual, hey, it's Gareth? And, just the first name only. It's very podcasty just to give your first name, isn't it?
Oh, it is. That's true.
I'm so used to saying it's Gareth Mitchell. But yeah, I'm happy to do first names. Makes it more friendly.
Here we are.
It's a podcast. So it is. Well, should we just crack on with it then?
Yes, we should, because we've got such a lot to get through.
There's quite a bit to get through. Let's do it. And coming up on this edition, bringing breast examinations to more women and indeed men. It can be a problem for men as well, breast cancer. Doing that more conveniently thanks to some novel robotics. We'll tell you about that. And we're checking out a new report on internet freedoms and how AI is compromising those freedoms. It's all right here on the Somewhere on Earth podcast. First up then, you're off to the pharmacy and you're going to get some headache pills maybe, or pick up that prescription. Oh, and by the way, don't forget the breast examination. Yes, a new device is promising to revolutionise how women monitor their breast health by bringing automated clinical breast examinations to clinics and pharmacies without women always having to schlep off to the hospital or the local doctor's clinic. So, Ghislaine, just to get us started on this, we're going to hear about the tech in a moment, but just tell us what goes on in one of these breast examinations, i.e. the non-robotic kind.
There are lots of technologies already used, like mammography, ultrasound, MRI, and also the down-to-earth clinical breast examination, which is a hands-on manipulation by the health practitioner. But for me, I actually, at the moment, my breast examinations in London at least, I go to a hospital and into a room which has a big machine with flat steel plates at chest level. And you're kind of pushed in to stand there and hold in the right position into this machine. And the nurse comes and she squeezes one breast in between and tightens up the plates like a clamp, tighter and tighter and tighter, and getting pressure coming from all sides of the breast, flattening the breast in several planes, yeah. And it is quite painful, to be honest, and it's quite undignified and awkward, yeah. But of course, then she leaves the room and they do the clicks and whatever it is that's happening in that machine, because there's lots of different machines. And that is a first level examination, yeah. And at that first level, other than the nurse fitting you into this very non-ergonomic thing, it's the complete opposite to the shape of a breast. I've always wondered about this.
Really.
Yeah, it is. It is like a modern medieval clamping thing. But there's no human touch other than the nurse putting you into the right position. Yeah. It's not like you are manipulated or pushed around. And I have wondered why it was not more ergonomic. I shaped to the breast, but I think our interview today does clarify some of that, actually.
Yeah, all right. That'll be interesting. And in fact, one of the points our guests make on the interview is how this procedure hasn't been particularly really updated for quite some time. It seems like for a very long time. So it might be due for a little bit of a rethink. So we'll hear about the pros and maybe the cons of this automated approach. We're going to get your views as we go along, Ghislaine, as well. So what we're talking about here is a robotic manipulator. It's been designed by a team at the University of Bristol in the UK, and the researchers are based at the Bristol Robotics Laboratory. And they've also been working with some people at Imperial College London who have helped them with the sensors, that side of the thing. So the people at Bristol, they're a mix of postgrads and undergrads. So we're excited about this story on many levels, not least of which it's great to have early career researchers who are getting into the spotlight here. So supervising them is lecturer Dr. Antonia Tzemenaki, and we're going to hear from her. But we're actually going to start with the lead author. He's one of these early career researchers, and he's George Jenkinson.
So what we've created is kind of a two-part system. One is this soft variable stiffness tactile pressure sensor. So this is a sensor that's designed to interact comfortably and safely, physically with people, because it's soft and made of, of course, safe materials. And the other part is a platform. So we usually refer to things like this as a manipulator, but it's basically a robotic platform that's capable of holding. The one that we've actually made is capable of holding 5 sensors, and we've shown that it can manipulate or control the sensors in such a way that it can cover a realistic breast morphology. So we work with what we call phantom breasts, which are basically like a breast made of silicone rubber that's modeled after a cast taken from a volunteer, and that was donated to us from our partners who we're working with on this project at Imperial. So we have those two bits of the system. We have the sensor and we have the manipulator, and we, of course, mount the sensors to the manipulator. And using that system, we can carry out this is kind of next on our list. Using our system, we can carry out a physical palpation examination and get some results that we hope will one day be medically useful.
So the device consists of a frame almost that the woman sits at or stands at, and then they kind of insert their breast, don't they, into the cavity, into where the device is. Can you tell me a bit more about what it looks like?
We're a research lab in university, so of course most of the things that we put out aren't immediately ready to be used by the participants or the users, but we've got some concept art of how we imagine the device to eventually look, and that's the idea. We want to make something that's kind of approachable and easy to use, and the way that we're imagining it so far is that the woman could, in our illustrations, perhaps, or the user, I should say, could be, leaning forward and doing something else, like reading a book or on their phone or something while the examination is going on. Of course, part of that is this is subject to how effective the examination is going to be, because the way clinical breast examinations are performed by professional people at the moment is they nearly always have the woman lying or the person lying on their back, because this is just through practice has shown to be the most effective way to do it. So it might be that in the end we come up with something and we say, okay, actually we need to have this person lying on their back. But at the moment, the thought is that you can sort of lean forward, you can sit down and lean and be comfortable.
Presumably because it has gravity on your side, and that helps in this context.
Potentially, yeah.
Yes.
Yeah.
Okay, of course. So give us a sense of what is actually going on, because we're talking about palpating the breast, aren't we? The breast tissue, as a clinician would do in an exam. So just tell me about that process, what a clinician does, and then indeed how your machine, the robotic version, is doing the equivalent thing.
Yeah, so one of the things that's quite interesting about this as a sort of space or as a service to investigate is that this is, clinical breast examinations using a hand, a physician or a doctor of some sort using a hand. That's not new, and that hasn't really. There's been no real technological or practical change to it for a very long time. So there are standardizations, perhaps within a hospital or within a practice, in the way that people perform these examinations. Generally, people say, I'm no trained expert, but generally the trained experts tell us that they do the palpation with sort of the outside of their hand and do a sort of press and drag motion, and they follow a certain sort of path, if you like, around the breast to make sure that they cover the whole area. But the precise guidelines of how to do this aren't that well established, and there's wide reports in medical professionals' confidence in doing this and in the kind of quality of results they're getting. So one thing that we are looking to do is standardize this. So if we have some sort of objective or at least repeatable method of doing a breast examination, i.e. by robotics, then we can assess in earnest how useful these kind of examinations actually are. So that there's a degree of transfer from how the professionals do it to this robot. We're hopeful that we can discover some new methods of doing it, or the way that's most efficient and effective.
A big part of the challenge here, presumably, is getting the machine to press with the same kind of dexterity and gentleness, I suppose, as a human clinical examiner.
That is correct. This is a huge challenge, and our conversations with public contributors who gave us a lot of feedback on the current examination methods did stress this. They stressed the fact that current procedures, current ways of examinations can be very painful. So we want, from one side, to limit this to make sure that our platform will be safe and gentle and comfortable, but we also want to make sure that we press enough, we have enough force to make sure that we actually have an accuracy in detecting whatever might be there. So the good news is that the sensors that we have created in this project, and there are two of those sensors, they both have what we call a tunable range of sensitivity. So they are able to inflate and deflate, and by doing that, we are able to change the range that it senses. It can sense some lump at the surface of the breast, but it can also sense something that is deeper in the tissue. And that is where the innovation of those sensors lies, really, because this is not what you often find in prior research.
Yes, because there are 5 arms, I suppose, like robot arms, for want of a better description, which makes it sound all very mechanical and horrible. But at the end of each one is a fingertip, effectively. But that's a little inflatable sac, isn't it? That's the key thing. It's a soft sac that, as you say, inflates and deflates as it makes contact with the breast.
Yes, that's right. And the fact that we have 5 or 3 or 7 fingers there is what will help optimize this examination method, because it can be faster, because it's not just one fingertip, it's more. And a very good analogy that I often refer to is the fact that when you want to create a robot that will wash your dishes, you're not going to make a humanoid robot that stands next to your sink and washes the dishes. You're going to make a dishwasher. So we want to learn from the experts. We want to see what forces and what movements they are applying when they examine a patient, but we want to learn from that and apply it in a different way that makes sense for a robotic device.
George, as well as applying the appropriate force to the breast, of course, crucially, there's a sensing function, isn't there? This thing is able to discern if it's touching a lump or some soft tissue, whatever. How does it even know what it's pressing against?
Yeah, so as Antonia said, there are 2 sensors that we've developed as part of this project. One of the uniting things between the 2 is, as she said, we have this change in stiffness that we control using pneumatics. So basically blowing up or deflating like you do with a balloon, right? Balloons are quite soft unless they're about to pop, and then they're quite hard. So the way that the 2 sensors sense and know what's going on is quite different, although they have some commonalities. So they both use a camera, and one of the advantages of using a camera is that we don't really have to push for the innovation, right? Over the last 15 years or so, cameras have been becoming really, really good, really sensitive, and really small because of smartphones. So they exist, and they're cheap, and they're great. So the way that the first sensor that has been developed as part of this project works borrows a lot from another sensor that we have at the lab called the TAC tip, and that essentially films the inside of the membrane. So if you imagine you have a camera inside this balloon that we're imagining, then when this touches something from the outside, the balloon sort of indents at that particular place. So you just by looking at the inside, you can see what's being touched. And if you do a few practice runs, then you can begin to characterize maybe how deep or how close or how big the indentation is. You can get an idea of force from that. And the other sensor that I've worked mostly with, we have, if you imagine it's sort of like a series of channels. So there are a number of pits just inside the elastic membrane, and these are sort of liquid-filled cavities, and these are coupled by tubing to another location, so that you have, when the membrane itself is touched, the liquid moves, and along the tubing somewhere, you can see this movement, right? So if you're looking at the tube, you're just seeing a bit of liquid go up and down, and you know that bit of liquid going up and down is tightly coupled or is touching a bit of the membrane at the other end. You can say, okay, that piece of the membrane is being touched right now. And then if it only moves a tiny bit, the contact is very soft. If it moves a lot, then the contact is with a high force.
Do you anticipate this kind of one day replacing the clinician, or is this more of a companion for the clinician? And of course, bringing this kind of examination to more women in more places more conveniently?
So yes, this is definitely not going to replace the clinician. It is very important to keep that clinician, as their expertise and input is invaluable. This is more of a complementary approach to the clinician, and it's in fact there to make clinicians' life easier and patients' outcomes better.
That is Antonia Tzemenaki, who leads the Dexterous Manipulation and Wearable Robotics group over there in Bristol. And of course, you heard there from George Jenkinson, the PhD student who is the lead author on all that research. Let's get some commentary and analysis from Glenn Boddington. We heard that graphic description there of the what it's like going for these examinations. What about, would you want to have the robot manipulation? Do you like the sound of it?
We'll be back after a quick break.
Learn how luxury, social conditioning and psychology influence our behaviour every Friday on the Luxury Mind podcast. Unravel myths and explore unseen influences with a healthy dose of humour. Join the Luxury Mind podcast on YouTube and on all major podcast platforms.
I do actually, because it's definitely got a slightly more human touch,
ironically,
sensitivity.
Yeah,
ironically, yes, yeah. It's interesting because I've worked a lot with robots and touch, and a project called The Blind Robot that we did about 8-10 years ago, which was about the kind of uncanny valley of being touched by a robot. Yeah, and this is a health discussion. It is a health discussion. There was a big discussion in Japan from the early 2000s, and then it started to come in across the world, yeah? And this very weird thing that people have, like, I'm not sure I want to be touched by a robot, let alone treated by a robot. But in fact, I think we're much more used to that today. And this sounds like a much more deeper tissue solution. And it gives you the privacy. It takes away from being touched by humans, which unfortunately can be abusive in these scenarios and are overdone, over-frequent, these tests, yeah. But let's not underestimate, it's a massive issue, breast cancer worldwide. And in 2020, I think it was 2.3 million cases of breast cancer across the world, both sexes, all age groups. And that's about 12% of all cancers, yeah. So, of course, what's very important is early detection, because then you've got a 90% survival rate. But in so many places, we have a very high amount of breast cancer in Europe, Australasia, North America, but mortality is higher in other parts of the world because there's less early detection. So the more that something like this could be out and about, get to remote places, maybe be flat packed with a few boxes with it and very easy to install and put up, and gives women the privacy and the chance to just go and get it done. Yeah, I think that's a very, very positive output for early detection scenarios.
Yeah, sure. I loved George's description of how they actually do the sensing. So I was wondering, how does this thing gauge the pressure? But I thought it would have some, kind of material that changed its conductance or something according to how hard it was pressed. But this is actually an optical sensor, a camera basically within one of these balloon sacks.
No, it's very clever, isn't it?
Really clever, yes. Yeah, exactly. Yeah. And it can infer the amount of pressure from the amount of flexing from as filmed or as imaged from the inside of the balloon. And didn't you just love it when Antonia said something like, if you're talking about a robot to do dishes, you don't just get like a humanoid robot thing that comes and stands at your sink. You get a dishwasher.
Yes,
it doesn't need to look like a human doctor in this case. I thought that was a great point. That's a quote I'm going to steal.
Yeah, no, I think that's a very good point too. And the fact that you could go into a room on your own and, deal with it one breast by breast, actually, and like they mentioned, maybe, do some text to your friends at the same time or listen to some music or something. It doesn't take so long. That, for me, sounds much better than being squashed between steel plates or being, manipulated by human hands, actually.
You could put some VR on, couldn't you? Like VR goggles or something like that. You would love that.
It would be immersion room.
Oh, exactly.
Immersion room with lots of wonderful...
Mrs. Virtual Presence in the room here. You'd love that. I don't mean you're a virtual presence. I just mean that's your thing.
Yes.
Goodness me. I can tie myself in knots. Right, before I go into even more of a spiral, whatever, let's move on. Glenn, thank you very much. All right, now let's talk about internet freedom. It's a bit of a change of subject because a report just out says that AI is hindering more than it's helping in some parts of the world when it comes to internet freedoms. Now, this matters because oppressive governments are getting better and better at using AI to automate censorship and then churn out tons and tons of mis and disinformation, basically to swamp out any dissent online. And regulation isn't exactly doing as much as it could do to keep up. That all, according according to a report from Freedom House. They're an internet freedoms body based in Washington. And journalist Emma Woollacott has just written about it all for Forbes, and she's right here. Hello, Emma. Welcome to Somewhere on Earth.
Hi, thanks for having me.
Thanks for being here. Right, so let's get into how AI is killing internet freedoms, because just that thought alone, Emma, I'll be honest, was a bit counterintuitive to me. I thought, well, we're always hearing this is all about democratising people's voices and so on. Not so, says this report, and indeed you.
Well, the point is that these tools can work both ways. So just as they're very productive for people, students wanting to write essays or whatever, governments can use them to produce disinformation incredibly quickly. And they can also use AI tools to filter out the sort of content that they don't like. And that's expanding more and more around the world. China is a particularly bad offender, but there's plenty of countries trying to do the same thing.
I had a feeling that China would pop up in this conversation, and Iran presumably. But then there are other countries that abuse their citizens through abusing internet freedoms are available, aren't there? And there are more, frankly, than I thought as well in this report.
Yes, absolutely. There's 22 countries out of the 70 that Freedom House looked at have laws that require internet platforms to use AI to automatically remove the content that they don't like for various reasons. Sometimes these are fairly straightforward tools, but sometimes they're developing their own really quite sophisticated ones.
Right. So, Glenn, it's not the most cheerful bit of bedtime reading you've ever done, is it, going through this report?
No, it's a very difficult conundrum at the moment, because we've got, like Emma said, this thing that could be absolutely amazingly supportive and assistive, but at the same time is like the other side of a coin is that it could do what it is doing harm, lots of harm in different places. And it's the same issue as we're talking about the release of, open source was such a utopic, wonderful thing. And yet now, of course, because it's all been open source is how it's starting to get misused. Yes. So double coin things. What I think is really interesting is how on earth we get to any kind of global regulation. And I'd like to hear from Emma more about that, because we haven't even managed that for nuclear issues or for climate change. We know that these constant fragmented global regulation debates that, the UN is always trying to pull together, but is constantly seen as failing on it. And yet, is it the UN? We don't know, it's everybody really. But Emma, do you ever think there's any possibility of global regulation here? That's like a big question and a bit naive, but...
Well, I'd say global regulation is fairly unlikely. The countries where it's most needed are the ones least likely to sign up for any sort of regulation. But there is a fair bit of progress being made. In Europe particularly, they're looking at an EU AI Act, which has sort of certain parallels with GDPR in a way, in that it looks at different areas of technology, different uses of the technology, and then obliges companies to behave in certain ways based on the perceived level of risk. So there's AI in political campaigning, chatbots, deep fake, all that sort of thing. They're looking at similar measures in the US, but rather further behind. There's an executive order from President Biden, sort of going through at the moment, I suppose, that has very similar provisions, really. But a lot of it is provisions against sort of day-to-day problems, like discrimination via algorithms, that sort of thing, and notifying people of how their data is being used, whatever. To an extent, governments are rather scrabbling around to work out how on earth to deal with this. It's all happening terribly quickly.
Well, I mean, this is the thing. It's just that age-old story, isn't it? That it's just where the technology is moving quicker than the regulation and the governance can
always,
keep up.
Than governments can keep up, and if they want to, like I was saying, some of them don't want to keep up anyway.
They so do not want to keep up on that.
And police systems too, of course, that just seem to go ahead and use them, possibly without even necessarily having discussed it with their governments. Yeah, so we know. What about regulation AIs? I mean, I know that, for example, AI-based tools and platforms, can be fact-checked. And journalists can use that kind of fact-checking AI and source-checking AIs and source verification. And I was just been in a few debates recently about the possibility of AI being self-regulating, having its own built-in mechanisms to setting its own rules and benchmarks and limiting behaviour of itself, but also possibly other AIs. I'm wondering, Gareth, if you've got any Emma? I'm really fascinated by this, yeah.
Well, as you were saying all that, I was thinking, probably not amazingly seriously, but has anybody actually tried asking ChatGPT to draft some global regulation and then indeed an implementation and enforcement strategy? Or would even ChatGPT say, this just won't work at the global level, back off, this is rubbish? I don't know, Emma?
Well, in the same way as you can use ChatGPT to detect AI-written content, you can use AI tools to detect other AI-produced content. So we've got there's a project called Geneva, produced by the Internet Freedom Fund, that trains algorithms to detect censorship system. Obviously, it can't then do anything to stop them, but what it can at least do is alert journalists, researchers, whoever, to the fact that this is actually going on. And there are other tools as well that do much the same thing. There's one called Tunnel Bear, another one called Siphon. So detecting it isn't necessarily that difficult, but obviously there's a limit to what you can do to restrict what's happening in other countries.
So are there other potential ways that AI could be part of the solution? We've talked all about AI causing all these problems and wreaking havoc, but I mean, can it help with tools to help people, I suppose, regain their voice, have an opportunity to circumvent censorship, any of those kinds of things, Emma?
And to be honest, avoiding censorship is more about finding ways to communicate where your government can't spy on you. So things like virtual private networks, maybe Elon Musk's Starlink, that sort of thing, actual private channels of communication.
So out of this report, we read the usual suspects. Iran and China don't come out particularly well from it. So what about on the good side, though, Emma? Are there any countries that are exemplars of sorting all this out?
Iceland ranked as the best country for internet.
Oh, Iceland's good at everything.
Yeah, and that's 5 years running. They've held that position. But Estonia does very well too. They're
good at everything too.
Yeah, they're an incredibly digital society. So it's a huge thing for them to try and get this stuff right.
Yeah, no surprise with those two. Were there any that might have surprised you, possibly, Emma? I mean, maybe not. And there's quite a few countries listed in the report anyway. But any surprises of any kind from the report?
The thing I tend to notice is just how many very reasonable countries are also using AI and internet censorship in one form or another, and obviously not to the same degree, but. Basically, if you think about it, most governments do this. There's a French bill going through at the moment requiring browsers to block particular websites. We have it in most European countries and in the US in terms of sort of blocking terrorist content or child sexual abuse material, for instance. And again, even in the UK, we've got things like the Online Safety Bill going through, the Investigatory Powers Bill, and if they require various platforms to try and monitor and use AI tools to filter out what the government has deemed inappropriate.
Yeah, all right, Emma. So what about you then back here in London, around the table with me as well? Parting thoughts from you, if any.
I do think we have to find a way to be able to use AI to detect the problems coming, even as Emma says, they can't stop it. But I think this pattern recognition of the misuse of AI needs to be grown. And it will grow, of course it will grow, because actually the feedback that's coming through across time will provide those AIs with indications of where areas of concern happen or where to look more, etc., And I still think, it is very interesting, I think, in the computer science scene, this debate about, could there be AI policemen who police AIs? I'd like to see that debate going deeper and further, yeah. And I also think that, mentioning Iceland and Estonia, it would be really great to have a lot of detail put in front of us as those two countries and others maybe as models, yeah. But actually then, not just our politicians, etc., but that us as individuals and humans can actually go, well, that would be a good idea if we did do that. That would work here and we could try that and I would do that and I am prepared to make that effort, yeah. The debate needs to be put much more out in public and on the table for us all to come up with solutions.
Yeah, learning from the people who do it well and indeed those who do it badly, and so that all of us can, I suppose, ultimately make the world a better place, he said, mildly naively there at the end. I think we'll leave it there. Emma Woollacott, it's been an absolute pleasure. Thank you for being here.
Thank you. It's a pleasure.
Marvellous. And Glenn Boddington, I've enjoyed very much finding my feet and our feet on this brand new podcast with you here. I think
it's great.
We're having fun. And we want to involve our dear, lovely listeners, mainly because, hey, folks, I'll be honest, we've launched a podcast here. We've put so much effort into even you hearing this. There are lots of moving cogs and wheels to even make this something that pops up on your listening device, whatever listening device. Sounds like gramophone or something. So please tell your friends, listen to us, support us, and we will love you very much. You can get in touch via hello@somewhereonearth.co. That's hello@somewhereonearth.co. And on WhatsApp as well, it's UK code 44, then 7486 329 484. Shall we have a bet on how long it takes me to learn that? So I don't keep reading it out. Let's see. I'll get it off by heart at some point. So that's, do you know any tattoo parlours around here?
Yes, we can do that straight after this show.
And then
if you
the
like.
following day they'll change the number and I'll feel stupid. So anyway, let's do that one again. It's code 44 7486 329 484. And we just get in touch, tell us what you think, suggest some stories. Oh, and I'll tell you what, a voice memo would be nice. We like hearing the listeners' voices. More of you, less of us. That'd be nice. So there we are. That'll do for now. Our sound editor today is the excellent Keziah Wenham Kenyon, and audio is by Stevie Arnoldi, who's a senior producer at Lanson's Team Farner. And our editor, still sane after spending so much time putting all this together, is Anya Literovich. Thanks, folks. That was lovely. See you next time. Lots of love. Bye-bye.